Hello, everyone. Thank you for joining us on today's webinar, the Palameda 2015 Year Review, the State of Open Source Software. If you notice on the right-hand side of the screen, there is a place to type questions. And we will be taking questions at the end of the webinar today. So please feel free to ask anything you want, and we'll try to come around at the end if we have time to answer any of the questions that you may have. My name is Jeff Luszcz. I'm the founder of Palameda, and I started Palameda back in 2003, which seems like forever ago, but also right around the corner. I'm Palameda's CTO, as well as I head our professional services team. That means I help companies discover, manage, and remediate any of their open source issues that they may encounter, help companies with baseline reviews, M&A work, as well as rolling out the Palameda software. Today I'm going to talk about a couple subjects, but mostly what have we seen happen in the last year in the open source world, specifically how companies are using and perhaps misusing open source. Topics that we're going to address today, number one is how has the software supply chain landscape changed over the last year? Are organizations using more or less open source, and are they more or less aware of the open source that they're using? What are the impacts of using more open source, broader open source adoption? Some lessons learned from the vulnerabilities encountered in the open source world and the use of open source this year. And then some things that you can do to improve your processes in and around open source usage that may be a good thing to do in this upcoming year if you're not doing so already. So first off, how has the software supply chain landscape changed over the last year? Well, let's talk about what the software supply chain is. This is everyone in the world that you get software from and you give software to. This may mean your commercial partners. This may mean your customers. This especially means the open source pipeline. So the open source libraries that you download, the open source code that perhaps you're cutting and pasting into your product, partners whose code and SDK that you're using, maybe outsourced development. All of these people, all of these companies, all these organizations are part of the software supply chain. And at each point, they are looking at your code, or you are looking at their code, and you may have some questions. We'll talk a little bit about what some of those questions may be in a couple slides here, but most importantly, what have we seen change? Well, first off, in 2015, now 2016, we see some of the software languages that are being used are changing. There's always new languages that come and go. There are some that are very trendy that look like they're going to be with us forever and then they disappear, almost to be never seen again. But others seem to have some sticking power. And 3 or 4 of the ones that we've been seeing over the last year that seem to really be catching people's attention are the following. I would say that the winner by far has been the use of JavaScript, especially with the Node framework. So JavaScript has really come in its own. Traditionally, people were using JavaScript for basically their web front ends, maybe to make things move or flash or change on your website when your customers are coming in or your users are coming into your web app. But in the last year, a new framework came out, which if you're not familiar with it already, I would recommend that you should take a look at Node. It is a server-side use of JavaScript, which is a kind of, in some ways, a little strange that traditionally this front-end language is now being used on the back end. But some of the ideas there were, well, if we have developers writing JavaScript on the front end, why don't we have them use JavaScript on the back end as well? We can use all the same tools, the same libraries, the same training, the same people. And it really seemed to hit in the last year that doing back-end development with this framework called Node in the language JavaScript is something that we see a lot of companies do. Many of them are startups, as well as many of them are trying out, they're kind of a larger, more traditional company, trying this out with new products or small services that they may be running. This is an environment that still has, I would say, a ways to go in terms of maturity. The tools are still coming up to speed. The kind of the best practices are still coming up to speed. But I would not be surprised if there are developers in your organization right now either shipping or about to ship a product based on the Node framework in JavaScript. And this is something that if you're on the business side or the legal side, you may need to change some of your preconceived notions about what JavaScript means and the licensing or the vulnerability concerns that you have as it moves from the front end to the back end. So if I was going to leave you with one thing in terms of new languages, it would be JavaScript and Node, something to definitely pay attention to. Others that we see to a certain extent that are simmering out there, there's a language called Go. There's one called Clojure that we see from time to time. These are smaller use languages. They have a lot of publicity. They have a lot of let's say local proponents. We don't see them in very large numbers in people who are doing open source development compared to all the other languages in the world. But they do have their vocal proponents, and we are seeing them in customer code and other review work. So again, things to be aware of. Go and Clojure, that they exist. They're kind of, they're traditional languages, but at the same time, you may not be familiar with them or the ecosystem or the kind of the best practices. And you may want to ask your developers if you haven't heard these languages before. Are we using them? How are we using them? They very often are mixed in with more of the traditional languages. So it's a good question to ask. The other new language that we see out there is kind of a cousin to an old language, which is Swift. If you're doing any mobile development on iOS, so for iPhone or iPad, your developers almost certainly these days are using Swift for new work. Very similar in some ways to the old ecosystem around the Objective-C. So it's not a surprise to see it here, and it's what we'd call the new normal for iOS development. In some ways, kind of just taking the mantle from Objective-C, very similar people, companies, and frameworks at play there. So that said, the traditional languages and frameworks still dominate. We've talked now about JavaScript and Node and Go and Clojure. Those languages, as interesting and important as they are a small fraction of the code that's being written right now. If you look at what are most developers, most software products, in the enterprise space and the non-enterprise space, are going to be the traditional languages: Java, C#, .NET, C, C++. Those really dominate the discussions, really dominate the lines of code or packages shipped and used. These may trend a little bit, I'll say, in the Java world, but traditionally this was an enterprise server-side language. But now with the explosion of Android, especially Android mobile, we are seeing Java being used as an operating system language. We're seeing it used as a end user application language, especially on the Android side. So kind of changing some of the legal and vulnerability best practices as Java moves from, say, something purely in the back of the house as, say, an enterprise language or a server language to now something that's being distributed on millions of devices. And that's some slight changes. And again, if you're in the legal world, you may want to update your feelings about what does Java mean and what are the approved licenses or best practices around the use of Java. Similar world for C#. Traditionally, it has been a server-side backend product, as well as the desktop. So traditional desktop applications in the Windows world are these days very likely being written in C#. In some ways, no changes there. Backend best practices remain there. The front-end application best practices remain there. But the explosion of languages, of libraries available for C# has really been telling in the last year. A lot of the libraries that were traditionally available, say, for other languages have been ported to C# or have had the moral equivalents written. And we're seeing a very rich ecosystem in the .NET world around open source libraries, especially with their availability. And that brings us to our last traditional language, C and C++. These are the languages of Linux. These are the languages of embedded or networking companies. So if you see a device that has a Ethernet port on the back, or if it has a Wi-Fi chip inside of it, almost certainly this is being powered at its heart by C and C++. We see this a lot in healthcare, in a traditional healthcare environment. We see this in anything with a networking stack inside of it. You're going to have at your heart C and C++, and almost certainly you're going to have Linux and GPL licensing concerns at the heart of these devices. So what's changed in how we use these languages? So there's been some changes in the languages that you use. There's also been a big change, especially in the last year, about how we pull in code written in these languages. So one of the big changes has been really the increase in usage of what's called repository management systems. And what these are you may have heard terms such as Maven, NuGet, Node Package Manager, things like that in the past. And what these are things used by the developers to manage their use of third-party software. So a developer may sit down and write in a configuration file a list of all the libraries that they need. So instead of physically downloading the libraries and putting them into source code management, which is the traditional way of including open source, the traditional way of including third-party software, instead what they do is they install a repository management system, and they write configuration files for the management system and say, please go download this library, or please go download a library with this version or any greater version than this. And what this allows is maybe a little more convenient management of products and their dependencies. If something gets updated out there in the wild, you can set your system to update your code base as well automatically. You can also make it very easy to say, I want to use this particular component, and let the repository management system handle all of the dependency management. So there may be dozens, if not hundreds, of other libraries that your choice requires. And so you basically outsource the heavy lifting to the repository management system. This has some pluses and minuses. I would say one of the big pluses is it's convenient. It makes it really easy to use open source. It makes it very easy for your developers to say, I'm going to use this and keep that item updated in your system. I would say the big downside is it's kind of a surprise sometimes what libraries you're using, what components you're using. If you say, I want to use this particular database, or I want to use this particular crypto library, it automatically will download dependencies that you were not aware of, or you did not look at or vet or agree to use, except through the use of the parent component. And this is really causing kind of some lack of visibility into what people are using. And sometimes a disconnect between what people think they're using and what they actually are using. We'll talk about that in a couple of slides here. But if you're going to take away one big thing about kind of a big change in development is the use of these repository management systems. So I have a small table here about some of the more common languages and platforms. And if you're not familiar with these repository managers, I would recommend that you go talk to your developers a little bit about, are we using these things? How are we using them? How are we managing the components that are coming in? Are we doing periodic reviews, etc.? So Java, for example, is the traditional one that we talk about here, and there's a repository manager there called Maven, which is where you would get all your compiled Java jars. In the C#.NET world, there's an equivalent called NuGet, which will download, say, your DLLs and other libraries, binary libraries like that. JavaScript with Node has the Node Package Manager that really, in some ways, came from nowhere and is now seen all over the place. And especially in Node, you will see typically hundreds of third-party dependencies being brought in, just to the nature of JavaScript having smaller libraries, smaller components, more of the Swiss Army knife approach of pulling in small pieces and wiring them together. And others that round out here, Ruby Gems, CocoaPods if you're doing iPhone development, and then the RPMs and debs that are being managed if you're building a Linux operating system or you're putting modifications or additions on top of Linux. So these are kind of the main ones that you'll see out there. There are dozens more, and I may have left out your favorite one here, but these are the ones that traditionally you would see if you were a larger organization. These are the ones that would be bubbling up across your engineer's desk. Very often, the legal team and the management teams may not be familiar that this change in development practices has happened over the last handful of years here. And it's, I think, one of the biggest disconnects between what people think they're using and what they really are using. And so my biggest takeaway is getting control of your use of third-party items brought in by repository managers is one of the best things you can do in terms of keeping track of what you're actually using. So what else has changed in the last year? Back in 2014, 2015, Heartbleed made a very big splash. We saw a flurry of activity back in 2014 when the Heartbleed vulnerability was first discovered, and there was this first wave of addressing this in the public world. Front page news everywhere, TV news even. How often do we hear TV news talking about software vulnerabilities or open source software vulnerabilities? But Heartbleed was one of those. Well, what we've seen in basically the last, say, let's call it year and a half, is there's going to be a long tail of upgrades and unexpected late disclosures. To this day, we still are finding unpatched products still running OpenSSL with the Heartbleed vulnerability in it. This is now a year and a half later. It was found in, I think, April of 2014 or March of 2014. You would have expected after that big push to get everything upgraded, everybody would have found all these. And I would say that the vast majority of items are still unpatched, uncontrolled use of the Heartbleed vulnerability, but kind of sitting out there. And I think we can generalize from this that there's going to be, with every vulnerability found, there's going to be the correct patching in that first month or two, but then a long tail of kind of almost zombie systems or stale systems that are out there that will not have these things addressed and found until there's either some sort of software audit or a problem with basically a vulnerability being used. And late disclosures is what we mean when you get a note about an upgrade and then buried down in the release notes is saying, we upgraded our OpenSSL to CVE XYZ. We see these things happening, a year or so later, very often due to kind of a software audit or some sort of usage of the vulnerability to get in. Because of this long tail, we're seeing more organizations requiring what we call real disclosures from partners. If you're doing something that's non-trivial and your disclosure list is a handful of items, it's a pretty good sign that it's not a real disclosure. We expect hundreds of items in a disclosure list, and if you're only seeing single items, maybe a couple dozen, and it's something real. You're paying serious money for either the product or you're paying serious money for the relationship, or the product has a manual that's hundreds of pages long. Our expectation is you're going to have hundreds of open source libraries there, hundreds of open source components. And so some of the more larger organizations or folks who have been burned in the past or have done their own light reviews are now pushing back on their partners, saying, that's great that you gave us this little list, but we just did a quick sniff test and we found OpenSSL, we found zlib, we found Tomcat, all the things that are not on your disclosure list. And the fact that these were not disclosed tells us that you're not disclosing the smaller parts as well. So expect that if you're playing with somebody in the top 50 or top 100 software companies in the world, that request is likely going to come when you deliver new software, especially if there's a partnership or some sort of reselling engagement. Linux-based devices are definitely paying more attention to the deep Linux issues, both on the licensing side and the vulnerability side. There's been some kind of famous lawsuits in the last year that have really pointed people down to the lowest levels of their use of Linux and the use of the Linux stack. And if you basically are selling something that has, my simple test is if it has an Ethernet port on the back or a Wi-Fi chip, pretty good sign that you are shipping Linux. And we can spend days talking about Linux compliance and the right thing to do and how to do it. But I still see the vast majority of companies who are shipping Linux-based devices from Internet of Things up to airplanes still have a very long way to go in terms of getting into compliance and paying attention to all the licensing and vulnerability issues there. It did change in 2015. I'll talk about that in a little bit here. We've seen kind of the push for deeper analysis in the Linux world, but there's still a long way to go. Non-phone use of Android. So basically people building devices with Android as the operating system. So instead of using Linux, traditional Linux, instead of traditionally using a traditional, say, real-time operating system or embedded operating system, we're starting to move to Android for all the standard reasons there. Lots of features, big community, maybe some good licensing, or at least the top end of things there. And they're becoming more popular. It's one of those things where we see if people are making a decision right now, Android is now in the top list of, are we going to be using Linux, Windows, or now Android? So that's a big change, and it's another good question to be asking your teams. If you are shipping a device, again, anything that's wrapped in plastic or a bare board, what's powering it? What is our operating system, and how are we staying compliant? What questions have we been asking? Are we actually doing our disclosure lists, etc.? We have seen an uptick in people starting to do deeper dives in the open source components, so doing scans and other deep analysis before they use the open source library. And this is especially in cases where people are saying we're moving from a proprietary framework to an open source framework, or we decided not to write this core piece because we feel that the open source world is in some ways doing it better than we would. But we also need to make sure that we're not kind of taking in things that we can't support, or as licensing that we can't respect for whatever reason, or is it that they're not paying attention to security or export control issues in the way that you would. So starting to see some of the larger companies add this as part of their component ingestion framework, saying, okay, either all or ones that have hit a certain kind of importance to the business need to get either a light scan or a deep scan. And then that helps them integrate themselves into the ecosystem a little more. They find problems, they can push those back upstream as opposed to going at their own. And that's another change we've seen in the kind of the use of open source is companies that previously perhaps would have kept licensing problems internal because they were either fixing them themselves or deciding not to use those libraries, those open source libraries, are now working more closely with the open source person or the open source team there to say, we don't like what you're doing here with this disclosure. We don't like what you're doing with this use of snippets that say stolen from XYZ. We can't ship any code that says that. You shouldn't be shipping code that says that. How can we get that fixed so we can use your component? And that's been a very nice change, I think, in how legal and engineering works with the open source world, becoming a little more, whether it's public or just reaching out, using private channels to get things cleaned up and to the level that they would ship internally. And then another word that you may have heard some buzz around, but may not really understand what's going on there is containers. We are seeing containers starting to be used all over the place, and now starting to be shipped to customers, or being kind of the expected way that your product may be delivered or used by customers. And containers are, I would say, the short story there. I won't quite do it justice here, but the idea of a container is much like when we moved from having real physical hardware to virtual machines, and that reduced kind of the weight of what it took to spin up a product as well. Instead of spinning up a huge piece of hardware. Now I can create and destroy a virtual machine at will. Containers, you can almost think of as lighter weight virtual machines. It's not quite doing it justice, but it's maybe a good way to think about it. And containers have all the concerns that we traditionally have around use of open source. Are we respecting the licensing? Are we complying with the licensing? Are we basically using black boxes and we don't know what's going on there, and inside of it there's 300 open source libraries and commercial libraries being used? So a good question to start talking to your dev teams and legal teams about is your use of containers. How are they being shipped? How are they being managed? Are you downloading random containers from the internet? That's a very common way to get a first system up and running. What's your policy around these things, and how have you expanded your open source policy to include containers? And I'm starting to see some movement on that there, but these things always lag behind. So as you're looking at your docs and your policies for the year, containers and repository managers are two things that I would highly recommend. You sitting down and thinking about how does this affect your open source usage policies? How does it affect your open source training? And what are your policies? What are your policies around containers and tracking containers, et cetera? So this brings us to kind of our classic question that we try to talk about and address every year is, are organizations more or less aware of the open source that they're using? And I always find that this is sometimes the most surprising element of this presentation every year, is just how much more open source is being used. And last year surprised even me. In 2015, we saw an almost doubling of known open source components in use by the people we work with. And what does that mean? Well, it means back in 2014, when we do our census, we saw about 250 open source components in the average or the typical review. Well, in 2015, the average or typical review was showing over 450 components. This is an almost doubling. You can see it here from the graph, where basically from 2011 to 12, 13, 14, 15, we see a kind of the drumbeat of more and more usage, more and more usage, more and more usage, and then kind of an uptick in the graph here. And I'll talk a little bit about some of the trends that I think are causing this uptick. But I think the important takeaway from this graph and this information here is this is the average application that we're looking at here, 450 items. Even last year, if you're looking 250 items. These are what you should be expecting as the baseline for either your products or the products that you're using. So if you don't get a disclosure list from your partner that's 200 or 300 or 400 items, you should be pretty sure that you're not getting the whole story. If you're building your own product, you should expect that your number is going to get even higher. These numbers in some ways always lag. These numbers show what people are about to release, not always what they're building right now. So I expect these numbers to increase, probably maybe even similar numbers this year. The other big takeaway from this is the percentage disclosed. That's the second column in this graph here, the orange line at the bottom. It's been my experience that companies are horrible at being able to tell people what they're using. That there's a lot of feeling that we're tracking this, we know what's going on. Oh yeah, of course we can tell our users what the list is. But when the rubber hits the road and you say, produce a disclosure list, produce a list of known open source, it's double digits at that. And last year, what's amazing to me is the average project could only disclose 8 items. And when you ask them, what are you using? They'll say something like, oh, we're using MySQL, we're using Linux, we're using Node, we're using Tomcat. Very large infrastructure pieces, typically handled by the IT teams instead of the developers. And that is always surprising to me, but then after doing this now for 11 years, it's not surprising. So your expectation is you're going to hear 20 items, 30 items on a bill of materials. What you should really read that as is add a 0 to the end. You should be expecting 200, 400 items. And the disclosure rate we saw last year went down to 2%, which is very small. I mean, that's almost like not having a disclosure list. And frankly, the average company has a 0-length disclosure list. So the average disclosure is 0 items. The fact that a few companies are able to disclose anything at all is what brings this off of 0%. And this is every company that I've ever gone to, this is the expectation, is very low list, or if there is a list of items, it was made that day. And maybe somebody went to the system and did a quick visual inspection or a grep, and they pulled together a list, but that was the first time anybody's ever looked at it. It's full of libraries and licenses that either are not shipped or have licenses that you would never want to disclose outside of your organization because you're not in compliance, or have known vulnerabilities that were fixed 2 years ago. So if you do get a disclosure list, it's also very common that it has not been vetted, it has not been reviewed. There's some tests that you can do, looking for certain components or versions of components or licenses that will tell you that it's kind of a auto-generated list that's not been reviewed by business, legal, and engineering. So what changed? And this is always interesting to watch year after year. Is how does our in some ways our industry remains the same, but there are some things that change. And what changed in the last year that really made that graph change? Well, there really breaks down to two things. There was more real open source usage. That's undeniable. That more companies who traditionally not used open source opened up the door last year. There was also more analysis. And so it's a little bit of, these things have always been there, but now people are becoming aware of them. And what I saw last year was a combination of both of these. So in terms of the more open source usage, executives, businesses, whoever you want to say is the gatekeeper there, has loosened restrictions on using open source. We've seen even Microsoft out there saying, we are shipping open source, we're using open source, et cetera, et cetera. More companies have been shouting from the rooftops that they are all about open source and use us, and we'll use your open source, you use our code, et cetera, et cetera. Please just open up the floodgates. We want to build a product that is the best of the open source world. So the floodgates have been open there in terms of using it. We see larger, more complex systems in use as well. So more and more embedded devices, more and more things like containers and virtual machines that are being produced and then shipped as the final product. And these complex systems have things like entire operating systems. They have things that are being managed by these repository managers or other coordination systems that people say, build me a whole device that has this operating system, this database, this security system in it, this, and this. Next thing you know, you are your own operating system vendor when you're building these containers or these virtual machines or these physical devices. There's use of many, many small packages, and what we see here is things like the jQuery ecosystem, the Node ecosystem, really trends to smaller pieces that then get reused. So maybe in the Java world or the C++ world, you might have a library like Boost that is tens of millions of lines large and does everything, but it's a single line item. As opposed to maybe in the Node world, you might have 300 or 400 or 1,000 libraries that do all the little things that one C++ library does, but it's smaller little pieces, more surgical. Use this little piece, use that little piece. And in the grand scheme of things, you might not be using any more code. There might not be more lines of code in the Node versus Boost example, but you're going to be dividing those modules at a much more granular level. And that can sometimes cause some management concern, legal concern, because instead of seeing one item, you see 300 items. That does cause some management paralysis and security paralysis and legal paralysis. And the package managers we've talked about before has greatly increased the open source counts, where all it takes is a developer to say, I want this, 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 and this, and you pull in a graph of dependencies, a dependency tree that pulls in a dependency tree, and so on and so on. It's become very easy to add a zero to the number of components that you're using. There's also been a requirement of more analysis. The level of expected analysis has increased. So much like I showed before with the you tell me 10, I expect 100 story, more and more companies have seen this, either been burned by bad disclosures, or they've done their own sniff tests at ingestion, or their customers have come to them saying, I got this note about Heartbleed update, but I never saw that you were using OpenSSL in your disclosed list of open source packages. There's a disconnect there. If you're patching open source vulnerabilities, but you're not disclosing your use of open source, it's going to make me call into question the whole disclosure list. And post-Heartbleed, we've seen that a lot. That's been one of the easy tests for people to say, am I getting a good open source disclosure list? Is, did they patch OpenSSL, but they never told me that they're actually using OpenSSL? What else aren't they telling me? The deeper analysis of Linux and the subsystems in use is definitely being seen. So for many years, people would just say, oh, we're using Linux, too complicated. I don't want to spend the money or the time to go deep into that. Call it a single line item, or not even disclose it at all. And well, you know, with some of the pressure, I think, being pushed by the Linux community, you know, the folks that are out there saying, you know, if you're using our stuff, you better be complying with the licenses. It's starting. I think it's starting to sink into the industry that Linux is not just a black box. It's not just capital F free. There are definitely obligations that need to be followed there, as well as companies when they see that they're getting things like physical devices, routers, containers that clearly have, you know, lots of Linux-based items inside of it. There's a real need for a disclosure list there. Even if all you're caring about is, say, vulnerabilities, you need to know what's going on there. So the legal teams have definitely increased their ability to handle larger component lists. I think this comes with tooling. I think this comes with experience. I think this comes with some maybe some good court cases that have kind of brought things to the forefront, and there's been some really good discussion on the legal lists and even in the popular press. So I can't tell you, you know, years ago when I started helping companies, I gave them a list of 30 libraries. That would be an amazing list. They would go away sometimes for weeks on this list of 30 to figure out what's going on. We've delivered lists of thousands of components in the last year, and I've been able to see the legal teams, at least certain organizations, to say, got it. We know what to do with this. We have the tooling, we have the people, we have the training, we have the experience to handle this. There's still going to be some edge cases. There's still going to be some things where they say, oh, you know, this is too weird to handle this license or that license. But we've seen people being able to add a zero to their ability to handle these things. I would still say there is perhaps a natural number that people are able to handle right now, which is maybe about 300 to 500 components. That seems to be kind of the number that's given to a legal and business and engineering team. That's a big chunk for them to process and understand how they're using these things, and are they shipped or are they not shipped. I see the true numbers going up higher than that. If you're shipping a router right now, you have like thousands of libraries, but companies are kind of handling them in 300 to 500 chunks. I think the legal teams are definitely going to be able to increase their ability as time goes on, but it's still something to be aware of. There is a natural, what's called high water mark, that is the ability of these teams to deal with, and we sometimes have to fight our battles carefully. What are the most serious issues here, or the traditional most serious issues? What are things that we should use as bellwether components or licenses or events to then expand our knowledge from? You know, this particular type of cut and paste, is this a big deal? And if it is, we're going to be worried about other things. You know, what's our use of Stack Overflow? We're worried about licensing there. What about our use of unlicensed components? Or how do we handle commercial code with Heartbleed problems? Those are the things that I see companies are spending a lot of time to figure out and then expand from. And then lastly in here is the technical due diligence process, especially on M&A, has allowed more review. The budgets have increased, the time has increased to a certain extent, because they know that this is their chance to get things right. Basically clean the bill of materials up. It also really allows them to get some good vision into what's actually going on in this company. These deep dives expose the languages that are in use, the component frameworks that are in use, the databases that are used, the commercial relationships that are in use. This is very eye-opening for people, and it's a good tool to get deep there. So what are some of the impacts on the broader open source adoption? What are we seeing companies, I don't want to use the word struggle with, but starting to put together a bigger team, a bigger budget, a bigger set of best practices. Well, obviously, if I suddenly have to deal with 500 items or 1,000 items in a typical product, there's more obligations to be followed. The legal teams are being kind of leaned on more to give advice and give are we able to ship this or not? And I would say that the obligations around the notice requirement. Some people may call it the attribution requirement, the notice requirement, basically a list of copyrights and other things that may be required in, say, your documentation or your about boxes or preserved in your headers. We are starting to see more pressure from, say, public company boards to say, we need to make sure that we're doing all the right things. We can't cut corners on this. We see pressure from the open source community saying, you got to give us credit. And so the change I see is more credit, more credits are being paid attention to, but that also still requires a lot of effort to collect those credits, correct those notices, make sure they're showing up in the right places, keep them fresh. It's one thing to do it once, but to keep it fresh. And I still think the industry has a long way to go before we're anywhere near even okay compliance with the notices requirements. But I've seen the change in the legal teams and the engineering teams in the last year, particularly. The people are starting to say, our customers are asking for this. We need to produce these things. We need to start putting this in place. The security updates obviously is a big deal. Heartbleed opened up the floodgates of loud public disclosures of widespread vulnerabilities, and that list, I think, is the vulnerabilities have always been there. They perhaps have always been being exploited, but now there's more pipelines about this information and where it may be, and just I think hear about a certain company having 1 billion devices out there. That's a big target. So what open source component is out there running on 1 billion devices or 500 million devices? And when we're talking about 500 items, 1,000 items per product, and you have multiple products on the same device, a lot to watch. We talked about the companies expecting disclosures, expecting the security updates. I've heard a lot of people say, you know what, I have a physical device, and I read about this, maybe it's an operating system vulnerability, Android vulnerability, or Heartbleed vulnerability, or OpenSSL vulnerability. I haven't been getting my update. Well, it seems that I'm on an end-of-life branch. Well, that's causing some heat and light and noise for certain organizations that are out there, because the older trees maybe not being patched the way the newer trees are, but the people still have those devices. They still have those applications. They haven't been end of life to the customers. Perhaps they have for the original manufacturer. And that's something that I'm seeing cause a little bit of unhappiness in the user community, where public open source vulnerabilities are being disclosed and talked about, known in certain areas but not being patched. As open source selection becomes a more widespread job duty, instead of it used to be more of the architect would pick it, now it's pretty much every developer has the ability to make a change in these repository managers and download it. We're seeing more increased training required. And in terms of what type of training is required, my opinion is you can't train this enough. It should be part of your onboarding, and much like your ethics and other types of training that you do yearly, in my opinion, you should be training about open source and license issues, copyright issues, vulnerability issues with your entire team every year. Enough changes every year that you should do it. And also, I find that onboarding process is often very confusing to people. It's often trying to get their job done while they're clicking through all these things. If you go take the middle of your team out for pizza or food or whatever fast food you want to do, and ask them some pointed questions about the GPL, or ask them some pointed questions about vulnerabilities, you're probably not going to like what you hear. I hear a lot of folklore, I hear a lot of misinformation, I hear just a lot of lack of information, and these are the people who are making the vast majority of your component selections, or the people who are being asked, are we okay? And I still see, even in 2016, a real severe lack of open source training and open source license knowledge in the line level developer, and I think that's a failure in our industry that we need to fix. And we also see that the legal cases are targeting the lower level components. We've seen some cases now in the last couple of years about people looking at 8 lines of code, 10 lines of code, and that really means that your microscope may need to come out more. And as you saw those previous numbers, the bellwether for me is if people aren't disclosing large components, they're not disclosing their entire application server or their entire database, I really can't expect them to be knowing what's going on in a cut and paste here or a file-based, file by file usage elsewhere in their system. So I think for as these cases increase, or potentially increase, it's a sign to us that we need to pay attention at the high level as well as the low level, especially if you're in certain industries or using certain technologies. So what are some of the lessons we learned from this year's open source vulnerabilities? First thing I like to say is I don't think open source has a worse vulnerability problem than closed source. I think there's many people who say that open source actually has a better track record around vulnerability detection, patching, fixing. So I don't want to leave anyone with any sort of misunderstanding that open source has vulnerabilities, is bad, etc. I think some of the best work is actually going on in the open source world. But what we're seeing is there are these long tails. There's just so much usage out there that we can't expect that just because a vulnerability was announced, that it's going to be fixed. And I like using Heartbleed, the OpenSSL component, as a great example here because everybody's using it. You probably have 25, maybe more copies of OpenSSL on the devices that you carry around with you every day. Each managed by a different team, each delivered to you by a different development company, and some organizations are better than others in terms of discovering it and tracking it. So we still find, as I said before, the versions of OpenSSL that are vulnerable to Heartbleed now over a year after the defect was first announced. So April 2014 is when people first announced it. I'm sure if I checked with my audit team today and said how many copies of the Heartbleed vulnerability did you detect, maybe 1 or 2 that were found in currently shipping products. I think this is a big deal. I think this is I look at this and this is one of the first things that I'll talk about when I do a report out with a company to say, you're still shipping Heartbleed. You're still, whether or not this is going to be a way that people are going to hack you or not hack you, your customer is going to look and say, how can you not have patched this? How can you not have upgraded this? How did you not know this was here after a year and a half? So my advice always is, make this a non-issue. Do what you got to do. Upgrade, patch, address it, get ahead of it, just so that you're not playing catch-up with it. Where are we finding it? First off, this unexamined code base is all types. The average development organization has not been looking for it after that week. If they didn't do it the week or 2 after Heartbleed was discovered, we're just not seeing a lot of mindful looking for these things. We see it embedded in commercial libraries and open source binaries all the time. So things that were compiled a year ago, things that were compiled 2, 3 years ago, almost think of them as being pickled. They're put there, they're working happily, but people don't know they're there. They're tracking commercial library foo or commercial library bar, and there was no open source disclosure about the use of OpenSSL there. And then we can come in and we find it buried deep inside that binary. Then the organizations now have to figure out how do we patch this? Can we go upstream and get a new version? Does our commercial license allow for that? And so on and so on. If you haven't put that together already, you should figure out how do you work with your commercial vendors to ask them about potential vulnerabilities, to ask them about getting upgrades based on that. So embedded in larger open source based components as well. You bring in something that's got 5 million lines of code as an open source library. You might not know that OpenSSL is in there. It's still the case that the average component, whether it's commercial or open source, is not doing good disclosures. You don't know that the envelope issues are there. And then the new one that was really interesting to me in this last year is about what I call stale containers or stale virtual machines. Again, another type of pickling where people say, we built an application for internal use, or this is how we deliver it to our customers as this virtual machine. And that virtual machine sits there happily running for years. And maybe the Linux operating system there hasn't been patched anymore. They haven't been paying for the upgrades, or they haven't physically been running the upgrades. Or maybe the operating system's been happily upgrading, but the use of OpenSSL in the product, the installed base problem, has not been upgraded. And this has been something that's come across my desk in the last year that is very interesting to me, because it shows that companies are starting to do a census of their virtual machines, are starting to do a census of all the business apps that they depend on, and what are they running on? Real hardware, container, out there in the cloud, etc. And just because something was shipped and the team maybe has moved on to something else, what are we doing? What's our next steps in terms of keeping upgraded, in terms of patching things like OpenSSL and others? And then the last thing just about this is Heartbleed was a great example of putting visibility on something that was not very top of mind for many people. This was a low-level component. It does a great job of doing what it does, but it's something that would never rise above the into the headline of features of your product. It was we need crypto. Let's pull in a crypto library. Not something that people were featuring. Now, as we look at people now doing larger works based on things like maybe it's software-defined networking, maybe it's things like operating systems, maybe it's things like pulling in all these NuGet packages, Maven packages, where we start to say, well, what are we depending on? What are our big pieces? What is providing our crypto? What is providing our networking stack? What is our operating system? And people are starting to ask those questions. Just because there's been no vulnerability reported for a certain library, in my opinion, that's almost worse. It means nobody's looking for vulnerabilities there. If you look at anybody's product, you're going to find a potential vulnerability. And the components that have no vulnerabilities, probably a sign that nobody cares, nobody's looking for them. Maybe, in fact, some of the worst issues for you. So we're getting toward the top of the hour here, and I do want to allow some time for questions. So let me just do this one last page here, and then we'll get to the questions. So you can't boil the ocean. And so one of the things I've seen people be very successful over the last year is when they're looking at their libraries, they're saying, we have 500 items, we have 1,000 items, we have 2,000 items. Where do we start? My opinion is you always want to have a full accounting if you can, but people can't get there right away. They can't boil the ocean. So where do we often recommend people start? Well, there's a list of 6 items here that I think are great places to start. You shouldn't finish with them. You should also figure out if there's things that are important to your organization or your particular domain. But if you look and you say, let's go ask pointed questions to our development team. What are we using to provide cryptography? And are we using multiple libraries? Are our commercial products doing crypto inside of them? What are they using? It's top of mind. This is Heartbleed. This is all the other OpenSSL issues that come out every couple of weeks. Not because there's anything particularly wrong with OpenSSL, it's just that people are looking deeper. So where is your use of crypto? What is your use of compression components like zlib? What is your use of multimedia, things like FFmpeg and others? Your application platform. So what does your whole platform run on? Is it Tomcat? Is it a certain version of PHP? Is it a certain version of Node? These often, again, are going to be looked at with a very close microscope, and often are going to have a vulnerability detector that requires you to upgrade your entire stack. And these are often very easy to find out from the outside. Sometimes the networking tools will sometimes even tell you, oh, I have this version of Tomcat, I have this version of HTTP daemon, I have this version of etc. So again, try to reduce your public visibility of these things to using stale components. And the last 2, databases. Great bellwether question to ask your team. I always like saying, what are you using for open source? Oh, we're not using open source. Oh, what's your database? Oh, we're using MySQL. Big disconnect was just found right there in terms of the team's understanding of what open source is and what they're using. And operating systems. I think you can't spend enough time just thinking of your best practices, thinking of how you're going to end up doing compliance here around Linux and others as well. So in terms of organization, let me just get here to the questions. I think we have about 5 minutes here, and let me go through here. Okay. There was a question about repository management features in Palamita, the product itself. So I'll just very quickly say, let's talk offline of that. We do have repository management features in the product, and we can definitely, if you're a Palamita customer already, we can talk about those things offline. Okay. Next question we have here is a question about zero-day vulnerabilities. So how to find and address zero-day vulnerabilities, and this is something I think is coordination of many tools, coordination of many best practices and many people. I would say in terms of zero-day vulnerabilities, I think there's a really good chance that if you're doing the type of analysis we discussed today, you may be somebody who's going to find a new potential vulnerability, what I call the envelope issue. You're using a open source library that maybe is not in the top 100 of what people are always talking about, but buried inside of it is maybe a particular version of a crypto component or a compression component or whatnot that does have a known vulnerability. Those vulnerabilities may be causing a vulnerability in that library that you're using. And that's for the people I've worked with who've been doing the kind of analysis for 0 days, and what can we do to get ahead of the reporting of the big pieces? You have to look for things like that, saying, I know that old crypto, old compression often is targeted as the way of getting into these components. Can I find that maybe this thing which hasn't been reported as having a vulnerability may in fact have a vulnerability? Okay. Next question is, can we send a set of the slides? Yes, as always, we'll be sending out a copy of these slides to all the participants, as well as I believe posting on our page here as well. So that's bringing us here to the top of the hour. I really thank everybody for joining us today. If you have any questions or comments and you'd like to follow up with us afterward, please send us information. You can reach me personally at jeff@palamita.com. I always love to hear feedback about these presentations. Love to hear what you guys are looking for. We often do in-depth private webinars or private sessions for folks, so please reach out and let me know if you'd like to see any new topics in the future or go deeper on a particular topic. As well as if you're not following us on Twitter, please do. We're at Palamita_Inc. And we will announce our new webinars there, as well as other news and nuggets that we find interesting in the open source world from day to day. Okay. Any last questions before we drop today? We have time for one more, if there are.